It has been a long time since the James Webb Space Telescope, operated by NASA, gave us a stunning first impression of the furthest reaches of our universe. This $10 billion telescope stands as the biggest and most powerful one in space. After capturing dazzling images, the James Webb Telescope uncovered something that NASA had been concealing about Mercury. Following this discovery, the U.S. immediately ended the mission. This seemingly ordinary planet is far from what it appears. As it circles near our gigantic sun, Mercury's scorching surface is scattered with astonishing peculiarities, including shimmering jewels. However, beneath its glittering exterior lies a colossal and mysterious core that challenges our previous scientific understanding. What other hidden secrets lie behind these astonishing discoveries? Let's explore the revelations that could drastically change how we understand this planet. Despite its small size compared to the Sun, Mercury shouldn't be underestimated. Beneath its extremely hot surface lies an abundance of complex mysteries. Recent Earth-based studies have revealed a surprising discovery. Mercury's surface is covered with precious stones. These unexpected gems exist on one of the hottest planets in our solar system. But this is just the beginning. As we delve deeper, we learn that Mercury's core is both mysterious and exceptionally large. These findings raise essential questions. What sets Mercury apart from its neighboring planets? What other hidden anomalies might it conceal? The Mariner 10 spacecraft was the first to reach Mercury, making it a pioneer in space exploration. It returned the first close-up images, revealing a crater-marked planet with odd ridges, much like our Moon. This mission shattered long-standing assumptions about Mercury's composition. It showed that the planet has a rocky surface, an unexpectedly strong magnetic field, a core larger than previously imagined. However, this wasn't the most shocking discovery. 30 years later, the Messenger mission changed our understanding of Mercury. Unlike Mariner 10, Messenger was designed to orbit Mercury, allowing for detailed long-term observations. It captured nearly 200,000 images, expanding our knowledge of the planet and revealing previously hidden regions. Among Messenger's key findings was the discovery of unusually high concentrations of calcium and magnesium on Mercury's dark side. This sparked interest in the natural processes that might explain these elevated levels. Additionally, researchers were surprised to find that, unlike other planets in the solar system, Mercury's magnetic field is significantly stronger in its northern hemisphere. These discoveries forced scientists to rethink their previous assumptions about Mercury's interior and geological history. On Earth, the movement of liquid iron within the core is primarily responsible for generating magnetic fields. However, Mercury exhibits a unique type of magnetic activity due to its distinct internal structure. But what else sets Mercury apart? Extreme temperatures and volcanic activity. Mercury's surface experiences extreme climate variations. Daytime temperatures soar to 860 degrees Fahrenheit 460 degrees Celsius, hot enough to melt lead. At night, temperatures plunge to -292 degrees Fahrenheit -180 degrees Celsius. Mercury's thin atmosphere does little to retain heat or regulate temperature, leading to dramatic shifts between day and night. But there's more to Mercury than just extreme heat. Recent studies have uncovered astonishing new features. In 2012, Messenger data revealed evidence of ancient explosive volcanic eruptions and signs of ongoing volcanic activity. This challenged the previous belief that Mercury had been geologically inactive for billions of years. Then, in 2020, scientists made another fascinating discovery. Some of Mercury's permanently shadowed craters contain water ice. Despite Mercury's proximity to the Sun, these regions remain cold enough to preserve frozen water, as they are shielded from sunlight. This finding raised new questions. Could Mercury support primitive life forms in these frozen regions? Could these conditions resemble Earth's coldest environments? This discovery has intriguing implications for our understanding of life's potential survival on other planets, especially in conditions that seem hostile to us. The Bepi-Colombo mission and Mercury's strange rotation. The story doesn't end there. In 2018, in collaboration with the Japan Aerospace Exploration Agency, JAXA, the European Space Agency, ESA, launched the Bepi-Colombo spacecraft toward Mercury. It is expected to reach the planet by 2025. Once there, Bepi-Colombo will gather extensive data about Mercury's surface composition and geological history. Interestingly, despite its closeness to the Sun, Mercury has both water ice and a strong magnetic field. But what's even more surprising is its peculiar rotation. A day on Mercury is longer than its year. When we think of a planet, we typically imagine it. 1. Orbiting the Sun once per year. 2. Rotating on its axis once per day. However, Mercury defies this expectation. A full rotation on its axis takes 176 Earth days. A full orbit around the Sun takes only 88 Earth days. This means a year on Mercury lasts only half as long as a single day. This results in some bizarre phenomena. As seen from Mercury, the Sun rises, grows larger, then appears to stop, reverse direction, and continue its path. This is due to Mercury's slow rotation compared to its rapid orbit around the Sun. But why does Mercury rotate so slowly? The answer lies in tidal locking. Over billions of years, the Sun's gravitational pull has gradually slowed Mercury's rotation. The planet is in a 3:2 spin-orbit resonance, meaning it completes 3 rotations for every 2 orbits around the Sun. This unique day-night cycle contributes to Mercury's extreme temperature variations. Mercury's thin atmosphere and unexpected magnetic properties. Mercury lacks a traditional atmosphere like Earth. Instead, it has a thin exosphere that is constantly depleting into space, replenished by solar wind, radiation, and micrometeorite impacts. Recent studies in 2020 revealed surprising information about Mercury's exosphere. Scientists had previously underestimated the amount of water vapor present. This water vapor likely forms when oxygen from Mercury's rocks interacts with hydrogen from the solar wind. Additionally, Mercury's fast orbit and slow spin significantly impact its magnetic field. Scientists were shocked to find that Mercury has a strong magnetic field, despite its small size and sluggish rotation. Its magnetic field is unevenly distributed, being stronger in the northern hemisphere. Further research suggests that Mercury's unique spin, orbit, and liquid metal core movements contribute to its magnetic activity. What's next for Mercury exploration? Mercury's slow rotation and fast orbit create challenging conditions for space exploration. For example, spacecraft must use complex navigation techniques, including multiple flybys of Venus and Mercury, precise speed adjustments. The Bepi-Colombo mission is currently using these techniques to fine-tune its trajectory. When it arrives in 2025, it will need to carefully manage its power and temperature systems to survive Mercury's extreme day-night cycle. As scientists continue to explore Mercury, new questions emerge about its core, surface, and the forces that shaped it. Mercury may be the smallest planet in our solar system, but it holds countless secrets that continue to fascinate researchers. Generally striking highlights of Mercury. One of the most striking highlights of Mercury is its immense core. According to planetary researcher Dr. Nancy Chabot, Mercury's core makes up around 85% of the planet's total volume. Interestingly, Earth's core accounts for only 15% of its total mass. This raises a significant question. Why is Mercury's core so gigantic? One popular hypothesis suggests that Mercury was once much larger, but lost a significant portion of its outer layers due to a massive impact early in the history of the solar system. This hypothesis, known as the giant impact hypothesis, proposes that a giant object collided with Mercury, stripping away its outer layers and leaving behind the dense, iron-rich core that we observe today. Mercury's magnetic field. Mercury's magnetic field, though weak, is also a source of great interest. Despite its small size and slow rotation, researchers were surprised to find that the planet has a global magnetic field, unlike Venus and Mars. This discovery, made by NASA's Messenger spacecraft, led to further investigations. Scientists also found that Mercury's magnetic field is asymmetrical. Dr. Katherine Johnson and her team observed that Mercury's radius is displaced by around 20%, which may be linked to variations in the planet's crust and how heat is released from its core. In 2020, further studies revealed that volatile substances such as sulfur, potassium, and sodium are present on Mercury's surface. These findings contributed to the growing body of knowledge about Mercury, making it one of the most fascinating planets in our solar system. Mercury's surface mysteries. As we continue to explore Mercury, its mysteries continue to unfold, challenging our understanding of planetary formation and evolution. Scientists are particularly intrigued by the presence of compounds that, at such high temperatures, would typically vaporize. Dr. Patrick Peplowski from the Johns Hopkins Applied Physics Laboratory has proposed that comets or asteroids could have delivered these materials much later in Mercury's formation. One of the most intriguing discoveries about Mercury is the presence of water ice in the permanently shadowed craters at the planet's poles. This discovery was made possible by the work of Dr. Nancy Chabot. These craters are so cold that the ice remains frozen. The possibility that complex organic molecules, like those that may have sparked life on Earth, are present there adds another layer of intrigue. Could Mercury, despite its extreme conditions, offer clues to the origins of life in our solar system? Mercury's geology and recent discoveries. Mercury's geology has also presented some surprises. Once thought to be geologically inactive for eons, new data from NASA's Messenger spacecraft suggests recent volcanic activity. Dr. David Rothery from the Open University in the UK discovered tiny, bright volcanic vents known as hollows, which provide insight into the planet's ongoing geological processes. These hollows, found on parts of the planet's surface, suggest that Mercury's geology may still be evolving. Another peculiar feature of Mercury is its chaotic terrain, a vast, disordered region near the southern pole, first identified during the 1970s Mariner 10 mission. Dr. Thomas Waters of the Smithsonian Institution suggests that massive quakes, triggered by the sun's gravitational pull, may have shaped this landscape. Mercury's core and internal structure. Mercury's internal structure is equally fascinating. Using data from the Messenger mission, Dr. Amir Khan of the University of Zurich revealed that Mercury has a large solid inner core surrounded by a liquid outer core, much like Earth. However, Mercury's inner core is significantly larger, which could explain its unusual magnetic properties. This surprising data challenges our understanding of planetary formation, showing that there are still many mysteries hidden in the solar system. The Messenger mission also revealed that Mercury has a thin mantle, only 260 miles, 420 kilometers, thick, compared to Earth's much thicker mantle. This thin mantle affects the planet's heat distribution and geological activity. Scientists found evidence of ancient volcanic activity beneath Mercury's surface, including shallow depressions called hollows, which formed when volatile compounds near the surface evaporated. In 2020, researchers found signs of a massive magma reservoir that once lay beneath Mercury's surface, shaping vast plains, particularly in the northern hemisphere. These volcanic plains, known as the Northern Volcanic Plains, were likely formed by massive lava flows early in Mercury's history. Further analysis of Messenger data in 2022 uncovered even more mysteries, including traces of nitrogen trapped beneath the surface. This suggests that Mercury may have once had a denser atmosphere that was later stripped away by the planet's extreme heat and constant solar radiation. The mystery of Mercury's ice. Another fascinating discovery involves the water ice found in the permanently shadowed craters at Mercury's poles. Despite its proximity to the Sun, this ice is shielded from solar radiation, remaining frozen. Some of this ice could be relatively young, possibly delivered by comets or asteroids over the past few million years. The presence of organic compounds in these frozen regions raises further exciting questions about the possibility of life or its precursors existing on the planet. Mercury's shrinking and geological activity. Mercury's geological history also shows signs of shrinking as the planet cools. Evidence of thrust faults, where sections of the crust are forced upward, provides insight into its past. Recent research suggests that Mercury may still be geologically active. A 2019 study found signs of ridges and small valleys formed by crustal stress, particularly near the planet's largest domes. This indicates that Mercury's outer shell is still undergoing changes. Mercury's unique magnetic field. Mercury's magnetic field is another area of interest because it differs significantly from Earth's. While Earth's magnetic field is generated by molten iron in its core, scientists are investigating whether Mercury's field is driven by liquid metal circulating around its solid inner core. This mechanism suggests that Mercury's interior is surprisingly active, similar to that of other planets and even stars. Additionally, Mercury's crust is believed to contain numerous cracks and fractures, which could allow heat and even fluids to travel between layers. This theory raises the possibility that, despite its dry and barren surface, Mercury could still have active processes occurring beneath its crust. Some researchers even speculate that hidden water reservoirs might exist deep inside the planet, remnants from a time when Mercury had a more temperate environment. If such water exists, it could provide crucial clues about Mercury's past and its potential for supporting life. The study of Mercury's interior structure holds the promise of further discoveries about the planet's history and its role in the formation of the solar system. The future of Mercury exploration. As scientists continue to study Mercury, they will gather essential insights into the evolutionary history of rocky planets, and perhaps even uncover clues about the early solar system. With each new mission, Mercury's mysteries deepen. Despite its small size and proximity to the Sun, the planet remains a treasure trove of secrets, offering researchers a unique opportunity to study how the Sun influences planetary evolution. Exploring Mercury's depths could not only reveal its hidden past but also expand our understanding of planetary science. With Mercury playing a crucial role in unraveling the early history of our solar system, future missions will aim to uncover even more mysteries, such as the exact mechanisms behind its magnetic field or the nature of its internal activity. Scientists are especially excited about the potential for finding signs of ancient life or conditions that could have supported life in the past. The discovery of water ice and organic molecules suggests that Mercury may have once had the essential ingredients for life. As Bepi-Colombo, the joint ESA-JAXA mission, continues its journey to Mercury, we can expect even more groundbreaking discoveries about this enigmatic planet in the years to come.